and you can call me Angie. And today I am here to teach you trigonometric function. Okay, so let's just get right into it. So first thing that I want you to know about sine cos tan is sine cos tan is the SOHCAHTOR. Okay, so which stand for sine, and as you know it's the opposite over hypotenuse. And then we have ka, which is for cos, and that is for adjacent over hypotenuse. And then last and not least, we have tan or tor. We have tor, which stands for tan or tangent, and it is opposite over adjacent. And this is not yet the complete stuff that we're gonna study about. There's still more to this lesson. So as you can see, after understanding the basics of sine cos tan, I'm going to talk about the reciprocal identities. So the reciprocal identities. So what does a reciprocal identity have? We have sec, cosec, and cot, where sec is the reciprocal of cos, which make it 1 over cos, and cosec is the reciprocal of sine, which make it 1 over sine, and cot is the reciprocal of tan, which make it 1 over tan. Okay, so after we understand everything about the basic sine, cos, tan, and we have sec, cosec, and cot, right? So I'm going to show you something. Just give me a minute. Let me open. So let's say that we got a triangle. As you can see, we have the sine which shows that it's opposite over hypotenuse, and cos which show that it's adjacent over hypotenuse, and tan which show that it's opposite over adjacent. So I'm going to give you an example of what we are going to do. So let me just say that I'm gonna make this what should we make it? Let's say I make the opposite side 4, the hypotenuse 5, and the adjacent 3, and I'm going to make I'm sorry. I'm going to find sine, cos, tan, and I'm also going to find sec, cosec, and cot. So how are we going to find that? First, sine is opposite of hypotenuse, right? And the sine is opposite over hypotenuse. So opposite over hypotenuse is 4 over 5, and that is sine. So we got sine, and then cos. We have adjacent over hypotenuse. Adjacent is 3. and our hypotenuse is 5. Okay, so next we have tan. So tan is opposite over adjacent. So that will be 4 over 3. Okay, since we have the basic side cos tan, now we can do sec. Since sec is the reciprocal of cos, so that would make it 5 over 3. And cosec is the reciprocal of sine, so that will make it 5 over 4. And since cot is a reciprocal of tan, that will make it 3 over 4. Okay, so since we understand how we can find sine, cos, tan, sec, cosec, cot, I'm going to move on to another lesson. And that would be, excuse me. And okay, so to make it easier, I'm going to insert a picture. Okay, as we can see here, this is called a graph, right? But then these are what we call quadrant. Okay, so what do we need to do about graph and quadrant? I just want you guys to know where would sine, cos, tan be plus or minus. So there are 4 quadrants on the graph, 1, 2, 3, and 4. And since sine is associated with y, it will be positive. Okay, let us write that down. Sine, and sine. So it will be positive on the first and second. I will repeat. It is positive on the first and second because it is associated with y, and in this side y is plus. So that means that it would be negative on 3 and 4. Okay, so now we are gonna do cos next. Okay, so what do we have for cos? Since cos is associated with since cos is associated with x, it will be positive on the first and on the fourth, and negative on the second and the third. Because it is associated with x, so this side x is positive and that side x is negative. So for the tangent, for the tan, since okay, like plus divide plus, it's going to be plus, so tan will be plus, and this will be negative, this will be plus, and this will also be negative. So let's move on a bit. Okay, let's just move on to the next topic, since we already understand what would sine, cos, tan be, negative or positive in which quadrant of the graph. Hello, okay, I want to talk about the unit circle. So what can we see here? We are going to look into the degrees that are associated with the circle. So we have 0 degrees, 90 degrees, 180 degrees, and 270 degrees. And if we go more, it's gonna be 360, and that is a full circle. So we need to know that we need to know them in radian. So 90 degrees in radian is pi over 2, and 180 is equal to pi, and 3 pi over 2 is equal to 270 degrees, and 2 pi is 360 degrees. Okay, so since we know the degrees and radians, we're going to continue to this topic. Now, how do we convert degrees into radian? Let's say we have 30 degrees. And what we have to do is we have to time it with pi divided by 180, and then we will get what we need. So let's just say we cut 0, 0, and that's gonna be 3 pi over 18, and that will be pi over 6. Okay, so we got our radian. So I'll give you another example. So we have 150 degrees. So we're gonna time it with pi and then divide it by 180 degrees, and then we're gonna cut it. So that means we'll get 15 pi over 18. So 3 times 5 is 15 and 3 times 6 is 8. So we're gonna get 5 pi over 6 radian. Okay, so now we know how to convert degrees into radian. So the next step is, how do we convert radian into degrees? Now let's see an example. So what we have here is, let's say we have 4 pi over 3. To convert it to radian, we would have to time it by 180 over pi. So pi, just cut pi first. Yeah, and then after doing all the calculation, we're gonna get 240 degrees. Okay, another example is 5 pi over 9. So we're gonna do the same, times it by 180 over pi, and that will equal to 100 degrees. So that is it for the trigonometric function. I hope you guys understand, and thank you very much. And be negative or positive in which quadrant of the graph? Okay, so now we have